Okay, this is something I've been wanting to make for a while. Um, but this is going to be kind of an introduction to Ansible and what it's for, how to use it, that kind of deal. First thing you're going to need is a server with Linux. Either, the easiest ones are Fedora or Ubuntu. I've got a Fedora server here, and I'm SSH'd in at the bottom. So that's kind of the prerequisites. SSH in with the user. This is Visual Studio Code. You can SSH in, and then you can edit files that are on the system. Like so. Hold on. You can go ahead and see how it's forward slashes. That's how you know it's a Linux server. It'd be backslashes if it were a Windows server. So you can open files, you edit and save, whatever. So, in my opinion, what Ansible is, it's just a way of developing really good scripts that are, when done properly, are able to run across whatever system you need. They can branch off very effectively, and you can just run them against servers that are already standing. Okay. There's also an infrastructure as code side where you could spin up virtual machines with them, but I'm not going to get into that. I'm just going to get into basic scripts essentially. So, that's where we're going to start. First, you're going to need the Linux machine, like I said, Fedora, Ubuntu, something like that. And you're going to need to install Python. So it's most likely going to be apt install Python 3, or it's going to be dnf install Python 3. Python comes standard on most distros that I can think of, distros of Linux. And their package managers are how they update their software, etc. In Fedora's case, in Red Hat's case, RHEL's case, it is written in Python, so Python's already going to be on the system. Okay? So for Ansible, the prerequisites are Linux server, Python. Next, with Python, what we're going to do is we're going to create something called a virtual environment. So think of it as just a folder you can activate to install modules and other things you would need in an isolated space where you can control the versions of everything almost like a snapshot in time or a container in this case. So how we're going to do this is Python 3-m, which if you ever want to know, Python-m, just run a built-in library module. Okay, so what we're going to do is Python 3-m, and then to create the virtual environment, it's V for virtual, then E and V for environment. And then what you're going to call the folder. In this case, I'm going to call mine, let's do virtual environment, just like that. If I do an ls, you'll see that is there now. So remember I said you can activate and deactivate these virtual environments. You do that by doing source and then the path to the actual folder that we just made, then bin and activate. And you can see right here, we are inside of the virtual environment. So now if we were to do pip install pip -- upgrade, what this is doing is pip is a package manager for Python, and we're going to install itself and just tell, hey, upgrade. So the first thing we're going to do, we upgrade pip, then we're going to do pip install Ansible. And that's the biggest and most basic part right there. So what we've done is Python 3, create the virtual environment, use pip to upgrade pip. And then we also use pip to install the Ansible module. So now what you're going to notice is we can actually type Ansible and it shows up as having all the options there, right? So that's part one. We have Ansible installed. Now, how do we use it? First, what you want to do is have a server to run scripts against. In this case, you can go ahead and run it against the server you're on, get the IP address, figure it out, you know. You can do. So, I definitely crashed. So, all right, guys, we're back. I talked a bit earlier, and I know the screens jump forward, but I need to convey two different concepts now. For Ansible, the way I'm going to teach you, and one of the most basic ways to understand it is there's going to be two sections, two main files, okay? There are the inventory file, which is where you house all your variables, all the server names and IPs, all the secrets, everything you would need that belongs to you and is specific to your environment. And then there are the playbooks, which is a series of plays or scripts or mini scripts that will actually run against whatever servers you choose that are housed inside the inventory. That separation there is so that when you create your playbooks or your scripts, you want to be able to modularize them the best way you can so that they are transferable between different environments, and all you have to do is fill in some variables. So first, I'm going to start with creating an inventory file, which is what I've done right here, right? So I'll go over this again. So touch inventory2.yaml. It's going to create the file inventory.2. I'm going to go and open that for you guys. At the top of your inventory is all. So that if you were to call all servers, that's what that means. You're calling all servers and all the variables attached to them. All is always going to be at the top. It's going to have children. And each time you indent inside a YAML, you're going down a level. That's what I'm doing here. That indentation is just me pressing tab. And with the YAML, you terminate everything with a colon. So that's why those colons are there. Now, the next part is grouping servers together. You can have things like web servers, email servers, right? Different things you can do. You can do group 1, group 2. Now, what you're going to do, this is up to you, but try to follow along. I'm going to create one called Raspberry Pis because I have some Raspberry Pis on my network. I'm going to create one called local server so we can run playbooks against the server we're on now. We have two different groups, right? Starting with local server. We want to specify what hosts, what servers are actually underneath local server. So hosts, what servers is what that means. Host name, PyDev. PyDev is going to be underneath the local server group. So if you're having trouble following along, group. Makes sense. So let me differentiate these. I have on my network 2 different Raspberry Pis. These 2, as you can see, are on the same level. And that's how YAML works, is basically you just indent. And you'll learn this just through repetition, okay? So here's the first section of an inventory, right? You might just have this local server, which is fine. I'm just showing you how you can evolve from this, okay? That's all I'm doing. Now the next thing we need to do, we have the servers, which we're using the DNS names for. We need Ansible to know what users to connect with. So with Raspberry Pis, most of you know the default user is Pi. So we're going to create a variable section or a vars section. Okay, this is where you can list any vars. So I can have one var be XXX and have that equal to my variable 1. Okay, that's how variables work in programming. But in this case, there's a built-in one called Ansible user, which will tell Ansible what user to use. So in this case, for Raspberry Pis, like I already mentioned earlier, we will use Pi as our user. And with the example you'll be following along with, so this is the group that you will be following along with more closely. Ansible user is the default variable. You can just go and type, who am I? And if that's your user that can use sudo, you put that there. So now we have the basic foundations of an inventory. Now, the keen-eyed of you might be thinking, okay, how it's got a user, how's it going to connect? So that by default in Ansible is going to be through SSH. Now you can change that using the Ansible connection variable, and you can change this to WinRM, which is Windows Remote Management if you're doing Windows servers, or you can specify SSH. I'm going to go ahead and specify SSH. Now you're thinking, okay, I've got a user, I'm connecting through SSH like I normally would, right? So SSH Braden at PyDev, just like you normally would. How does it authenticate? So there's a variable out there where you can specify where your private key is located. There's another variable called Ansible become pass, which, oh wait. There are, okay, so if there's a variable that you can look up. These are all baked in. Anything that leads with Ansible underscore is probably a built-in default variable. But if you need to specify a password connection, it's going to be Ansible password, and then you can type your password here. So if your password is password 1234, that's where you would have that. Okay, so that's your inventory. This is the most basic settings that I can break everything down to, you know. Take a good look and try your best to figure out what's going on. Group at the top level variables and then hosts. Notice with the indentions that underneath the variables section, everything's indented underneath. Basically, that's how you know this is the variables section. And then with hosts, it actually goes back out. So normally, if you're typing, you would just do one backspace, type hosts, and it's going to be at the same level as variables, right? It's a section underneath the local server group. So now you understand how to at least proceed. We've got a username, we have a password, we have a connection type. Let's go on from there. Next is the other side called the this is the playbook section. So I'm going to touch the play.yaml file. I'm going to go and open it. And in here is where we specify a name. This is going to be on every single section of the playbook or script. It's just what's going to output to the console. Just think of it like that. My first playbook, okay? That's what we have there. This is where we can specify what hosts run against it. So in this case, I'll do local server. I think that's what I called it, right? So now we know what host it's going to run against. Tasks. Now, this is where you actually get into Ansible and how it works, okay? Okay, so you might be wondering why I'm bringing up the docs, and it's to show you how to look at these different modules and be able to read and dissect them. So each module is going to work in a fashion like this. Okay. So the very first thing I'm going to have you do is with the playbook, remember me saying it's a playbook of many plays or a bunch of scripts, right? So the first way we're going to look at a playbook is being a collection of executions. So the first thing I'm going to do is have it only output to the console right here. So this is going to do the equivalent of me saying echo hooray, right? That's what this is going to do. And to do that, we are going to use the built-in module called debug. So normally you could just put debug here and that would work, but they're going to go to these fully qualified paths. So Ansible is where it comes from, the built-in Ansible, hence the name built-in. And then the module debug, it's just a fully qualified name for a module. But in essence, we're using the debug module. Okay. Now, it has the parameters you can use, which are very good to read up on, right? Message is obviously what I used. And it has a comment, the customized message that is printed. So it's just echoing to the terminal, right? But what this is really good and used for is down here. You can see examples. So their example that they use is print the gateway for each host when defined. So it uses the debug module just like I showed you. Their message is going to be system, the variable. So in Ansible, when you call a variable, you put these two brackets around it. So it's called the variable inventory host name. So that is going to be, in my case, it's going to be PyDev. That should be printed out. Has the gateway Ansible underscore. So it's one of those predefined variables that there's a list out there. You can go and find them. Ansible default IPv4. So whichever interface Ansible is interacting with that is IPv4 enabled, call out the gateway section underneath. So that might sound a little confusing, but it's essentially doing this. You know how you can do ifconfig? It is basically grepping or just getting the variable gateway in their case, but in our case we can do inet and it will grab inet. So that's what it's doing. But in our case, I'm literally having it echo out echo Ansible. So you followed me this far. Let's go over one more thing. We are going to run the command Ansible-playbook, which means we're calling Ansible and we're running a playbook. -I because we're passing an inventory file into it. So my inventory is called inventory2 YAML. And then after you're done passing in the inventory, which is the -I, you will pass in your playbook, which in my case, we'd name play.yaml. So when I break down what's happening, it loads all this information in, okay? Then it goes over to the playbook, and it goes, okay, what am I to do? I output this to the screen. I run this against local server hosts. So then it would go back over here, make sure local server is good, see what hosts underneath it. So it's going to run against PyDev. Then it's going to say, what are my tasks? Right now, my only task is to run this debug module. That's what's going to happen. And there we go. It ran successfully. So let me explain the output. Like I said, after we ran it, it goes to play, and it runs that very first thing like I said it would. It outputs that to the console. Then it does what's called gathering facts, which is when it loads all these variables in, like I mentioned. And it also pings the servers it's going to connect to, which it's able to do. So it says, okay. And then it SSHs into them and runs whatever module you want against it. So in this case, it's this debug. So now you get the basics. Now I'm going to do something different. One of the very first things in this video I showed you how to do was to DNF install Python 3, which grabs Python 3 and installs it, or apt install Python 3 if you're on Ubuntu, right? I'm going to show you to do that with Ansible. And I recommend you guys post all this stuff to GitHub, which I can make a video about. So, Ansible, DNF. They have modules for the DNF package manager and also the apt module. So, since I have both on my system, I can work through how to do both. I'm going to start with DNF because that's what my server's running. So, to better follow along, my debug /echo, I'm going to do my DNF install of Python. You're going to start off with the name like you always do. Install Python 3 on DNF-based distros. Right? It's just a comment. So, what is the module called? Oh, it's called Ansible built-in DNF. I'll copy that and you can paste it there. Right? How do we use it? Obviously, I want to install Python 3. You can look at the examples. So, this first example, it says install the latest version of Apache, right? So, it's calling the DNF module. HTTPD is Apache. It's just a different name for it. So, maybe that's not the best example. Okay, here's a better example, right? So, install the latest version of Apache and MariaDB. So, it installs Apache and the MariaDB server. It has a list here. Do you see that? So the name section is just calling whatever you want to pass in, DNF install git, right? That's what name is here. So name Python 3. And if you see here in the state, if we're unsure what state means, we can scroll up. State is to whether install present, which means install it. Latest would bring it to the latest version. Absent would remove a package. Okay. That's pretty cool, right? We have different options here. So in this case, I want the latest. So I'm going to do state latest. Okay. So that should work. That's it for the DNF section. My apt install of Python. Now we're going to do apt if you're on Ubuntu. Install Python 3 on apt-based distros. Ansible.builtin.edit. Let's see their examples. Very similar, huh? So their first example is installing Apache, right? You can tell that on APT's package manager, it's actually called Apache 2 instead of HTTPD, right? So you specify the name just like you do with DNF, and then you specify the state. Let's see, they don't use latest here, so let's scroll up. They have latest though, so we're going to use latest. So we're going to do name Python 3 state latest. Okay, we are nearly done. Now, you might be thinking, how is it going to know what to run DNF on and what to run an apt on? And that is a very good question. There's a couple ways of going about this. The first way I'm going to show you is you take here's what I've done. Here's one way of doing it. You can separate the playbooks and their tasks or scripts / the modules they run, you separate them by calling different hosts for different sections, right? So up here at the top level, I'm calling local server, which is my PyDev guy who runs DNF, is a Fedora base. He runs these tasks, right? But when I'm done with these tasks, you can see that I'd be indented like way out here. You basically just go all the way back, just like you would line up right here, right? And in fact, you can copy that, make sure everything's lined up just the same, and you basically start over. And what I'm doing is I'm running a different playbook or set of tasks against the host Raspberry Pis. And then I break down what tasks they are done here. That's one way of doing it. Yep. So I'm going to go and run that playbook just like we did. So again, it's Ansible-playbook, passing an inventory file, which is the -i. So inventory2, and then play.yaml. Okay, first error. So you need to learn to read errors and debugs, right? How to debug things. It does this. It does everything it did last time, right? First, it reads out the first name. Literally goes from top to bottom the way it works. Runs against a local server, which has the PyDev server underneath that group. Pings it, make sure it's okay in the gather facts section. Runs my first module run, which is what this one's called, where it echoes out to the command line. That passes, and then it would go on to install Python 3 on DNF-based distros, right? So the error here, because it failed, is this command has to be run under the root user. So you know that if you were to do DNF install Python 3, it would say the same thing. This has to be run with super privileged users, super user privileges. So here you type sudo, right? Ansible has a thing called become. And what become does is it's very similar to Linux, where you type su as in switch user, and you can choose what user to become. So in this case, for this section, we need to become root, right? So become true. We want to become yes. That's the same thing. Become true. So we're telling, yes, we want to become a different user. And if we leave it blank, it's going to have us become root, sudo. Just like if you were to do sudo su, you become root. The way you change that is become user user 2, whatever. In this case, we're going to leave become true. So we're going to become root whenever we do this. I'm going to go ahead and set that down here too. And with this, since it's not actually one of the variables underneath the module, this is one of the things you need to understand. It's not a parameter for the app module. Become is just a section of Ansible where it says, for this module, step back, do you want any other parameters that Ansible has baked in, like become? So that's why it becomes on the same level as the name and the module. Now you will probably need to come over here and have the Ansible password and maybe even the Ansible become password. Password. That's essentially what that is. It's Ansible become pass, I'm sorry. That's the default. So, the reason I don't have to do it is because I have my servers configured a certain way. So, it passed. Okay, let me go over everything that happened. This is why I selected the things that I did. So, just like before, my first playbook runs against a local server, goes down to the tasks, runs the before it runs the tasks, it gathers facts, pings the servers, right? So, gather facts underneath the local server. The local server has the host PyDev underneath it, pings it, okay. Runs the debug module, that passes. Runs the install Python 3 and DNF based, that passes. Then it's going to go back and say, okay, that section of the playbook's done. We're going to run my second playbook, which is where it starts here. It's going to run against the Raspberry Pis group. And when this gathers facts, it pings the servers underneath that group, like I've been showing you. In this case, bpy and backpy. bpy is online, backpy is not online, which is why it failed. And then it proceeds to only run install Python 3 on apt-based distros against the server it can talk to, which in this case is bpy. And it runs it, and that's how it works. And that's essentially how Ansible works. And you can do things like create full-on scripts where you install programs, you remove programs, you stig certain servers, and it's a way of building the script once and deploying it against a variety of different servers. If this portion was too complicated, let me show you something different you can do. You see how I have different playbooks essentially? Well, let's get rid of this section where it actually breaks. Where it breaks down and calls the Raspberry Pis group. That's gone. We're going to call all servers here. And let me show you what would happen normally. It would try to DNF install things on an Ubuntu-based system, and it would try to apt install things on a Fedora-based system, because you're running these modules against every single server, right? As you can see on the DNF, it tried to install it on the Raspberry Pi, and on the apt section, it tried to install it on the Fedora-based. Can't have that. There's another way of doing this. So back to when become is on the same level as the Ansible module, you can do if statements. So how Ansible does it is, when this condition is met, you do this. And this is what I am going to teach you guys how to use Ansible for. Remember how you can define your own variables, such as xxx equals my variable 1? So, in this case, what you can do is do something like distro type, simple, right? Ubuntu. And that's underneath the Raspberry Pi section. We're going to do the same thing over here. Fedora, right? Same variable, different, same key, different value. So same key, which is distro type, different value, which is Fedora or Ubuntu. When this variable is equal to Fedora, and in this case, when distro type equals Ubuntu, what this is doing is as Ansible goes down one by one by one, there's no win condition for the debug, so it'll run on every single server that is called. When it gets to the DNF section, it's going to go to the win condition or the if statement. Basically, when the condition that the variable distro type is equal to Fedora, we will run this. So what this is going to do is, for each host, it's going to go and say, okay, is this variable here? It is. And for local server, it's Fedora, so I'll run against that. Oh, it's Ubuntu for the Raspberry Pis, I won't run against here. And then vice versa with the APT section. So let me show you how that works. Do you see right there, guys? That is what I'm talking about. Where it says skipping. I know I've gone over this a couple times now. So install Python 3 on DNF-based distros. This section right here. It goes down to the win condition. And if the distro type variable is equal to Fedora, it will run. Which in this case, pydev has that variable equal to Fedora right here. Right? And for the Raspberry Pis, it's equal to Ubuntu, which is why it skips bpy. Now, vice versa, down here with the app module, when the distro type equals Ubuntu, it runs. So, bpy has that variable that it's granted from being underneath the Raspberry Pi group. That variable is equal to Ubuntu, so it runs against bpy. Well, transversely, down here, the distro type is Fedora, so it skips pydev. Right? So, why did I show you that? Because you can also do things like name. We're going to add a new section. My first Windows. Ansible works on Windows. Now, there are different modules. So the Linux ones are the default. Ansible.built-in is for Linux stuff. Ansible.windows is the Windows modules. But a lot of them have the exact same modules, right? So, I guess debug's probably the same, but like for, let's do update. So that's the equivalent. We've been doing apt and DNF. So for Windows, obviously Windows, they do everything through Windows Update. So Windows has their own module called Windows Updates, right? And you can call out if you want the security updates, critical updates, the update roll-ups, right? Here's an example of all these different things. So, Ansible.windows. We'll just copy this. Let me explain. Category names, star. Star is a wild card in programming and computers. That means anything that matches. So if I do ls down here, you see it shows everything here. If I do ls star, it shows everything. Which, what it did, it went ls, it lists inventory 1, inventory 2, and then it lists everything underneath. Okay, so if I want to do, yeah, you get the idea. It means everything. Reboot, yes. Well, let's go see what reboot means. Ansible automatically reboot the host if it is required to continue to install updates after the reboot. So if Windows is like, you need to reboot your system, it'll reboot it for you. And yeah, it'll sometime, yeah, that's the whole idea there. What you can do here is when operating system equals Windows. And that's how you can differentiate between all these different things. So if you do have a section, which I will go ahead and make, my Windows group. Okay, so this is where it gets a bit more complicated. We haven't done anything different. We just have set our hosts, just like the other groups. We're going to add a variable section in which we already defined that we are going to have one called operating system, and it's going to be for Windows. And we're going to need to specify a user. Now, remember back when I was showing you guys how there's a built-in way to choose your connection type. So here you would specify for Windows if you're going WinRM. In my case, I have SSH set up on Windows already, so mine's going to be SSH. Okay, so all I've done so far, made a new group, introduced a Windows box. Same concept, right? Not much has diverted. The only difference really is I need to specify the connection. You know, required difference, because Windows by default won't have SSH installed. And then I've added another play to our playbook. You know, I've added the Windows update. So if I do our Ansible playbook, pass the inventory file in, and run things. Well, it failed to connect. Hold on. Okay, there's a good time to show you guys that you can actually specify IP addresses also. So here's my IP address to my Windows box that I have. Instead of the host name. Failed to create temporary. Whoa, guys, that's a weird error. Okay, so a couple things here. You guys are working with a live thing. This whole error right here, this is because debug probably has a Windows counterpart. I'm gonna go and guess, so I'm gonna just throw a win condition. Distro type equals Fedora, or distro type equals, you know what? There's two ways of doing this. Or distro type equals Ubuntu, or you can do when distro type is defined. It's like, does this variable exist? So that will solve this problem. It won't try to run the debug, right? Oh, wait. Okay, well, that's still a good lesson to learn. Oh, I know what this is. You have to specify for Windows. You have to specify. Hold on, guys. I didn't think I'd go over any Windows shit. Okay. Yeah, so that's a little shell type CMD. Cool. So now it knows to use command prompt rather than try and use bash, which is what I think it tries to use by default. Bash or shell, one of the two. Okay, so that fixes that very first error that was gathering facts. I thought it was going to be the debug module. So, whatever. My first Windows run, the conditional check operating system failed. Okay. Evaluating conditionals. Operating system is undefined. Okay, so I must have messed up. It's probably a typo if I had to guess. No. Okay. Weird. Oh, okay, guys. So, okay. This is basic programming here, guys. So, why I just learned the error here, if you could guess, is the new section that I have for my Windows group. It does not have distro type defined. So, to fix that error, we basically would do this. Distro type is defined and its distro type is equal to Fedora. And then down here, since operating system is not defined on the Linux side, we want it to be defined and the operating system to be equal to Windows. So clear, let's go back. Okay, see, now it's working a bit more as intended. And this is my first Windows run, so let's hope that it goes well. I'm doing it live. Awesome, it worked. So with Windows, Ansible, it does take just a little bit more setup, but in the end, it will run the same way. You just have to specify connection type and all these different things, right? Built in for Linux, Ansible.Windows for Windows. So let's go back over what we've done. Not much has changed. This debug only runs when distro type is defined. So let's see what it ran against. It skipped my Windows server because distro type was not defined here. Clearly. It is down here, which is why it ran against the Pies. With the DNF, distro type has to be defined, which it's not for the Windows section, which is why it skips it. And the distro type has to be Fedora, which in BPie's case, it's equal to Ubuntu, so it skips it. Then vice versa down here. And then finally, with Windows, its conditional is that operating system is defined, the variable operating system is defined, and the operating system is equal to Windows, which that is meant for only the Windows group, and it runs it against it. And that backpie is still offline. I wanted you guys to originally see how it would look with multiple computers in a group, but if I just comment that out, it is like it was never there, and it works. So that is a big breakdown of everything that there is with Ansible. You know, the very basic level. I know it's a lot to think and regurgitate. You don't really need to memorize how to set up the virtual environment or Python or anything. But you just, as long as you understand how the inventory works on a small level, you understand that there are groups, you know. So in this case, group 1, group 2, and then each group has variables and then hosts. That is a lot of it. And variables are what makes this powerful. That's what it's programming. It's choosing on and off switches, you know. And there's one more thing I really didn't go over, and that's encrypting variables. So, like, obviously, we have an Ansible become pass. That's your root password. There are ways to encrypt them, so it ends up looking something like this. You know, and then just it looks something crazy like this. You know, just hashes. And I could go over that. You can Google that pretty easily. There's also other systems you can integrate to store your secrets, which is what we've done. I've done before. Very powerful stuff. And the built-in variables are a bit to think about, but when you start making your own to do things like these win conditions, that's when Ansible becomes really powerful, and you can have on and off switches and all these different branches you can go down, right? And this is really getting close to what is infrastructure as code, essentially. Being able to spin up servers through these Ansible modules and then eventually Terraform. Different things, but really the hardest part of this, in my opinion, after you come back and you're done reflecting, the hardest part is having the knowledge of how to connect to each of your servers, right? So for me, I didn't have to enter passwords because I have private keys set up. I already had SSH installed on my Windows box. I didn't have to do that. I could make a video on how to do that. You can use IP addresses instead of host names. But the hardest part really is just distinguishing between Windows and the Linux boxes, and it's not that big a deal realistically when you look back. And then there's another thing called roles, where basically you can take all this and put them into little files to just organize things better, right? Just organization, different files, just put things up. But that's how Ansible works, and that's my best explanation. It's very long, but I think this is enough to get you started and to get you to the point where you could like go and get a job using the stuff, in my opinion. Just a day or two of doing things like this, messing with it, understanding and looking at how in YAML you have to space things out. I've tried to comment very well on that. The one thing I didn't go over well is the tick. Just that's like it's a thing. It's a array. It's a list kind of thing. But yeah, that's the video. It's my very long Ansible video.